Good day, ladies and gentlemen. I welcome you all to Shitu's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you should kindly subscribe to my YouTube channel. Click on the subscribe button, hit on the bell to get the notifications of my videos whenever I upload. So now today we are going to be looking at separable variables. Separable variables. So you can see they ask us to solve the differential equation 4y plus y squared dy equals minus 2x plus sy squared dx equals to 0. So now, before we can solve this problem, I would like to give us a brief definition of separable, or when we can call it differential equation to be what? To be separable. So the differential equation of the form dy dx equals to f of x over g of y is what is said to be separable. That is, from here we can have this to be g of y. We try to cross multiply, we have what? We have dy equals to f of x what? dx. So what we are trying to say in the sense that you can see that we have the variable y with what? With differential of what? Of y, and same time we have variable of x with differential of what? Of x purely. You can see now, therefore they are what? They are separate. We have what? We have y, function of y and its derivative separately, and we have what? We have function of x with its derivative what? Separately. So that's if you can now transform your differential or your given equations in this form, so we call it what? We said it is what? It is separable. That's the brief meaning of what? Brief definition of what? Of the separable variable. Understand? Or what you can call a differential equation separable. So now what we are looking for, we are just looking for the y, that is our dependent variable y. Understand? So what are we going to do now to now bring out the y or a y? So therefore we need to differentiate the two with respect to x and y. You understand? So to get our solution. So now that's what we are going to do. So now from here, this will now be integrating with this. They have dy, that is g of s dy, plus c, that is constant of integration, then f of s dx plus what? Plus c2, the constant of integration to the second one. So now we have this g of x dy equals to f of s dx plus c2 minus what? C1, because this is constant here, so we try to bring them together. So now from there we can actually, we have gx dy equals to f of x dx plus c. Therefore we call c2 minus c1 to be just one arbitrary constant. That is c1. So this is the method we follow in solving problem like this. Are you getting it? So now, given this, so having this, we are going to solve. We are going to use this to solve this. Whenever you are given the problem in terms of this, you try to transform it in this form. Are you getting it? Then the next thing you are going to do is to integrate with respect to x and y. Then you solve further. So now let's say we have this. This can actually be, so you can see that the first time of this one we have y here. Automatically y can actually be out like this. Then we have 4 s squared dy. And also if you look at this one now, you can see x is what is common. So bring out x, we have 2 plus what? We have 2 plus y squared, then ds equals to 0. So now the next thing to do, you now use your brain. Understand? You think very well. That's what can you do to this, so that we have y separately and its derivative, then you have x variable x separately and its derivative. So now what are we going to do now? You can see that if you try to take 4 plus s squared here, we have y dy. If you try to take 2 plus y squared here, we have what? We have x dx. So now what are we going to do? We are going to divide through by what? 4 plus s squared and what? And 2 plus y squared. 4 plus s squared and what? And 2 plus y squared. Then this over this, understand, 0 0 over this will still give us 0. So now what are you going to do? So the next thing, you can see this one, you cancel this one, you have y dy over 2 plus what, y squared, plus y squared, then minus. So what do we have here? You can see this one, you cancel this one, we have x dx over 4 plus what, s squared, which this will give us 0. Are you getting it now? So now if you look at this one here, you can see that it is separable here, understand? So now we can say from here, equation, let's say equation star, understand, that is which is separable, variable was variable, or you said it is what, it is separable. So now having this one, and the next thing to do is to integrate with respect to y and what, and x respectively. So now to do that, so we have this y over 2 plus y squared dy, then minus we have what, x over 4 plus s squared dx, which is equals to the integration of what, 0. You integrate 0. So now to do this one further, we are now going to use the fact. Use the fact here, that is, whenever you have the differential, whenever you have integral of f prime of x over f of x will be equals to limit f of s plus c. Understand? With that. So now we are going to be using this fact to solve or to integrate this problem here. So now what are you going to do here? You try to write this one in the form of this. Therefore you have this, because you try, if you look at this one, 2 plus y squared, if you try to differentiate this one, we have 2y. Understand? So therefore, if you now have the derivative of this, or understand, you now be said, you will say ln f of s plus c. So now what are we going to do here? You manipulate 1 over 2, 2y over 2 plus y squared. You can see the 2 here and 2 here can actually cancel, that is, cancel themselves. We can, this one will cancel this, because we want to use this fact. That is why we are, what's it called, doing it or taking it in this, in this form. Also for this one, we do the same thing. So we have 1 over 2, 2x over 4 plus s squared ds equals to what, c. Because when you integrate constants, we have what, we have c. So now from here, the next thing to do is to now use this fact. To use this fact, you can see the differential of what, of differential coefficient of 2 plus y squared is 2y, and at the same time we have it as the numerator. Definitely we have 1 over 2 to the ln of what we have at the down, that is 2 plus y squared, minus, same thing here, if you differentiate the denominator, we have 2x and we have 2x at the numerator, this will be half of what, ln 4 plus x squared equals to what, c. You can actually see c, so let's try to give this c ln c also. You can see c, do not say ln c will also give us what, will also give us constant. So therefore we haven't changed anything. Understand? We just want this to be in line with what we have at the left hand side, because this one is having ln, this one is having ln, this one. If we now put this one also to be ln, definitely, so we want to bring out things together, understand, common things together. That's why we put it there. But as we put this ln here, it doesn't change anything, because it will give us what, it will still give us constant. So now, so c the same thing as what, as ln c here. So now from here, what's the next thing to do? We have half here, we have half here, understand? So half can come out, we have ln 2 plus y squared minus ln 4 plus s squared equals to what, ln c. Understand? So look at this one, and half is multiplying this. So when you say half to also multiply this, understand, we still give us constant, but because we want it to be in this form. So now what's the next thing to do? The next thing to do is try to use logarithm rule to solve this. You can see when you have length, this is log, the same thing as log. Division, no, division log. So therefore, we have 2 plus y squared over 4 plus what? S squared equals to half what? Length C. You can see we have half length here, we have half length here. Automatically, this and this cannot be go. So we have what? We have C to be equals to 2 plus y squared over what? 4 plus S squared. So, or we can put it in this form: 2 plus y squared equals to C into bracket 4 plus S squared, where your y squared can be C into 4 plus S squared minus what? Minus 2. So that is what? That is the solution to the problem given to us. You can see how simple it is. So where your problem is this place, you try to make sure or to transform it. If you could able to transform it in what? In separable variable, as we have from the beginning when I was giving the definition of separable variable. But if you could not do that, you find all means to transform it and you could not get that, definitely you cannot use this method. So you use another method of solving differential equations. So this is how you can solve the problem or the equation that is separable variable. So that is the end of today's lecture. If you have any question, kindly hit the comment box and ask your question, and do not hesitate to subscribe to my YouTube channel. At the same time, hit on the bell to get the notifications anytime I drop new videos. Thanks.